Hi, welcome to LB0 Fox India Norwegian Ham Ventures. I'm Morten, LB0 Fox India. And today we're going to take a look at a device that my buddy Simon SA6TIG asked over in the Terrace Discord if the next time I got some things from AliExpress through my sponsorship, if I could test. And that's this little thingy. It's the AT14 and it's a remote antenna switch or a remote coax switch. So Simon asked me to take a look at this and see if it's actually usable or not, and if that's something for him. And if it is, I have no use for this. I have another antenna switch which is remotely operated. So Simon's going to get this if this thing is good enough. And just to get the formalities out of the way, this video is sponsored by AliExpress. And if you haven't heard about AliExpress, well, you've probably been living under a rock for the last couple of years. But AliExpress is an online marketplace where you can get pretty much anything. And I usually say that by anything, I mean anything. And it's, well, at least fairly close to anything. I use AliExpress for ham radio gear mostly, just because there's a good selection of everything there. Everything from the really cheap and really bad to the really cheap and really good to actually the really expensive and really good stuff. So there's something for everyone in every kind of quality range and every kind of price range over on AliExpress. So let's take a look at this thing here. This is a 4-port antenna switch, as I mentioned earlier. It has a control unit here. Let's see if I can show you that. 4 positions with an LED that lights up on the input. That is powered by a 12-volt connection here. It's got a standard 5.5 by 2.5 millimeter plug. I think same as in your ICOM 705s, your Zygoos, and most other ham radio gear. 4 ports. Let's just remove these caps here. It'll make the rest of the job so much easier. This thing is rated for 500 watts according to AliExpress, and it has a rated range of 1 to 60 megahertz. So it's an HF switch. Let's see if I can get it to focus again. And we're not going to test the power limit here because, well, I don't have anything powerful enough to test 500 watts through this. But I am, however, going to test the frequency ranges here and see how that works out. There's also a cable here, 6 lead cable. I've just used an Ethernet cable because that's not included in the package. You can actually get by with a 5 lead cable because there are 2 ground connections on it. Let's see what else. I think we're going to do some measurements now. So let's open the box up. Let's take a look inside, what's inside, and then we'll do some tests with both a multimeter and a NanoVNA here. And we have 4 Phillips screws on the back here that we need to take out. And this is what it looks like on the inside. So let's zoom in and take a closer look. And this looks surprisingly good on the PCB. Nice thick traces for the RF connectors here. 4 solid relays. I don't know anything about relays, but we'll zoom into the relays and see what they are. And a couple of capacitors here. For me, who don't really know electronics that well, this looks pretty good. So let's get my phone out and zoom into the relays, and at least we can see what they're called, and perhaps some of you guys know more about them and can tell me down in the comments. And speaking about these relays, they're not latching relays, so at the moment you cut power, you lose connection to the antenna port, so you need to have this unit powered on. Let's take a closer look at the relays here. Let's see if I can hold this still enough. It says, I got 2 cameras that I need to focus now. Let's see if we can make that happen. They're called RT424012, Shrek, China. I have no idea if this is a good relay or not, but this is what's on it. Let me know down in the comments if this is any good. And that's the short overview of the PCB here. So let's close this up and test it with some test instruments here. And I have to say though, the case is really, really well made. It's out of thick, nice sheet aluminum, and looks like it can handle some degree of handling. So let's get the multimeter out and check for continuity between the ports, and hopefully not between the ports, and what happens when you disconnect a port regarding ground, if it's got a common ground or not. So let's see what happens. And we're got port 1 selected, as you can see here. So we're first of all going to check if there's continuity between the common port here, labeled TX, and port 1. We have ground connectivity, and we do have a common ground along the ports here. Let's check the center pin. Yep, got a connection there. Do not have a connection there. Not there. Not there. And let's check the center pin as well. Not there. Not there. And not there. So, seems to be switching. Let's switch this over to port 2 just to do a similar experiment. Yep. And we still have a common ground. So, seems to be as it should be here. What we're going to do now is we're going to get the NanoVNA out. We're going to measure SWR through the antenna switch for the HF bands. See how that is. And then we're going to measure insertion loss, first of all, between the common and one port with port open. Then we're going to measure insertion loss, or we're going to measure port isolation by just selecting a different port. And then we're going to measure isolation between the active port and the non-active port. I'm going to go through and show you how to do this. And this is thanks to Bob, who I had a LB5JJ over at Radio Hyperactivity, which I had about an hour call yesterday discussing the test methodology. Because, let's be honest, I don't know everything, and this is something I don't really know anything about, but we'll get some results nonetheless. And I got my NanoVNA here, and I got a dummy load because we're going to measure this into a dummy load. So I'll put a dummy load on port 1 here, just to simulate an antenna. And then we need to calibrate the NanoVNA. So first of all, we're going to calibrate this for SWR measurements. So let me zoom in a little bit, and we can take a look at the NanoVNA and the setup process here. And hopefully you can see this good enough. I'm going to tell you while I'm doing this how to do this. First, we're just going to check that there's one trace active. There is. And it's going to be reflected power. And let's see here, we're going to go back, set stimulus from, let's set it from 1 megahertz to, let's do the whole 60 megahertz that this is supposed to do. And then we're going to calibrate it. So we're going to go back. We're going to press calibrate. We're going to press reset. I like to always reset it first. And we're gonna measure at the end of this cable just to have as precise calibration as possible. So we're gonna press calibrate. We're gonna do open, and we have these test standards here. I'm gonna get them out for you. And the way you tell these apart, let me just shuffle them around. The open one has nothing in the middle here. The short one has a pin in the middle. And then you have the load one, which is a 50 ohm load, which is kind of two-colored. So that's how we tell them apart. But we're first going to do the open. I'm going to screw the open into this little jumper cable here. Press open. When that's done, we're going to remove the open one. We're going to insert the short. Press short. That one's done. You can see that there's a little bit of a check mark here. At least I hope you can see that when it's done. And then we're going to do the load. And that's all we need to calibrate for this test. And then we're going to do a little bit more calibration for the attenuation measurements we're going to do later on. But let's go back, and we can save this. And let's just save it in one of those spots here where, let's save it in the 140 to 148 here. I always do a calibration nonetheless, but it's always nice to have a saved setting in case something happens. Then we're going to disconnect this one, and we're going to insert a PL plug adapter to this. So let's go ahead and plug this in and see. So we got the connector here. Let's plug that in to the common port and see what the NanoVNA says. Okay, I have apparently calibrated this. No, I haven't. We got to switch it to port 1, which is relatively important. Let's see if we can get this in frame. It is now on port 1. I had it on port 2. Then it showed a high SWR. So let's zoom into the NanoVNA here, and we can take a look at the measurements. You can see that the SWR is beneath 1.25 across the 1 to 60 megahertz span. Let's just start at the bottom. We have a 1.105 SWR at the bottom here at 1 megahertz. Let's just check the bands here. Let's see here, at approximately 80 meters, we have 1.111, 60 meters, 1.017, 40 meters approximately. There's only 101 measuring points on this, and when you do it through a 60 megahertz scale here, it's going to be some big jumps. But at approximately 7 megahertz, we're at 1.023, so pretty much a flat SWR here. At 30 meters, we're at 1.037. At 20, 1.05, so nothing here. Let's see here. Let's just move up here. Once we get to 10 meters, we're at 1.1. And let's go up to 50 megahertz here to 6 meters and see. At 6 meters, we're at 1.2. So nothing to be worried about here. SWR through this as expected, and for all practical purposes, this does not affect anything. And now it's time to disconnect this. And then we're going to do the other measurements. Then we need to recalibrate. Let's just get this open up. And for calibrating, my friend Steve over at Temporarily Offline Ham Radio has made a cheat sheet for setting your NanoVNA ready for meshing attenuation. So this was actually really helpful for me. So I'll leave a link to Steve's channel down below and check it out. He's got a lot of great content. But I'm going to just leave this over to the side. You don't necessarily have to see it, but I need to see it in order to actually calibrate this thing correctly. So first of all, it says to, and I'm going to get this guitar pick here, which is my stylus. We're going to go back, we're going to choose display, make sure that only one trace is selected. It is. And I'm going to zoom into the NanoVNA so you can see this a little bit better now. Once this is done, we're going to tap back. We're going to choose format 2.1 through. And we're going to choose log mag. And that gets a little bit of a check mark on it. Then we're going to go back 2 times. We're going to test stimulus, and I'm thinking we need to test this for a broader range so we can see actually if this is useful on, let's see if it's useful on 2 meters and 70 centimeters. So let's measure a 500 megahertz range here, and we'll see how attenuation is. So we're going to press start. Let's do it from 1 megahertz and stop. 500 megahertz. This is actually a giant step. We're going to go back. We're going to go calibrate. We're going to reset it once again. Then we're going to press calibrate. And now we're going to go through all these steps here. So we're going to open, do the same thing. Find the open dingus here. Insert it here or screw it on here. Calibrate to open. That's calibrated. Then we're going to do short. Let's see, this has a pin inside it. Hope you can see that. Short. And we're going to load. That on here, press load. Then we're going to do isolation, and then it says move load to S21, which is the second port here. And leave everything else as it is. We're going to press isolation. Then we're going to go through. And then we need another coax jumper here, which I have here. We're going to insert the jumper here and interconnect these 2 cables. We're going to remove the load here. And we're going to add that to port 2 here. So what's happened now is that we have this jumper going through all the, probably not have that connected with the metal to the metal there. So we have everything connected. Both ports are connected, and we're going to press through here. That's done. Done. We're going to save this. Let's save it here. Now it's saved, so now we're just going to connect everything here. And I'm going to zoom out so you can actually see how I connect this up. And I actually disconnected here before I started recording. That sometimes happens, that I forget that I'm actually doing a recording here. So what this is going to do now is it's going to measure how much attenuation we have in here. Or how much insertion loss, first of all, through one of the active port and the common here. Let's get that up and running. We're just going to get a couple of adapters on here. And ideally, we don't want to see any attenuation now that the port is open. Let's see if that is true or not. Connect the SMA jumper cable here and connect the SMA jumper cable and the barrel on this one. So ideally, when we want to see as little attenuation as possible, we're going to zoom into the NanoVNA again. You can see we're between TX, also called common, and 1 here, and we're on port 1. This is the active port. So let's zoom into the NanoVNA and take a look. And hopefully you can see this. We have relatively flat curve for the beginning here. So let's go all the way back. We have 0 dB attenuation at 1 megahertz. Let's see where we start to see a change here. At 75 megahertz, well, all the way up to the rated 60 megahertz, we're at less than 0.02 dB attenuation. That's good. Let's see where we get the first dip. It starts dipping around 135 megahertz. At the 2 meter band, at 145 megahertz, we're at 1.42 decibel insertion loss here. So perhaps not ideal for 2 meters, but yeah, relatively usable. Let's check 70 centimeters here. And there we're going to see some different results. At 435 megahertz, we have 4.1 dB attenuation. So I wouldn't use this on 70 centimeters, but then again, it's not intended for 70 centimeters. It is 0 to 60 megahertz switch here. So we're just doing this test just to take a look. Now we're gonna change, let's see if I can get this in frame. Now we're gonna flip it over to port 2, leave the leads as they are, because now it should be as much isolation as possible, as much attenuation as possible between the ports. So let's see here, we got 85, 90, 100 dB here. It's probably not that accurate once you go that far down, but about 80 dB attenuation all the way to, let's see where it starts to rise. We have it up to 50, 60, 75, 80. Let's see here. It starts rising up at about 90 megahertz. And this is important if you want to use this switch to actually switch between radios and not antennas. Then you don't want all the energy of the radio transmitting going into these other ports and damaging your other radio. So for HF, this seems fine. Let's see, for 2 meters, we have about 49, 50 dB of attenuation between them. And let's go up to 70 centimeters and see. It actually has the least amount of attenuation at 310 megahertz, which is not a ham band. And if we move down to 435 megahertz, we're about 38 dB attenuation. So again, this shows that this antenna switch is ideal for HF and not really the higher bands. And then we're going to do a final measurement here. We're going to flip this back to port 1. And we're going to measure between one active port and one inactive port here and see how attenuation is there. Then I'm just going to put a dummy load in here to simulate an antenna. And attenuation between the selected port and the not selected port is actually not as much as I'd like to see. It is less than 70 dB all the way to 10 megahertz. And then rises up. For the, let's see, for the 10 meter band or thereabouts at 30 megahertz, 60 dB of attenuation. So better attenuation, the lower in frequency you get. And hopefully these numbers make sense to you. Hopefully this will make you make a decision whether to get this or not. What we're going to do now, we're going to get back to the studio. We're going to draw some conclusions on this and see if I think this is worth buying or not regarding how little it actually costs. So, what do I think about this AT14 antenna switch dingus? Well, at approximately $50, which it is over on AliExpress now, it is a lot of value for the money. And it does actually deliver on its promises. So I can't draw anything from that. It seems solidly built. As you saw, the PCB is great. The attenuation is well within what I expected. The insertion loss is well within what I expected. And the SWR is well within what I expected. So I can't find any flaws on this. And for approximately $50, it's a huge thumbs up for me. It'd be a huge thumbs up for twice the price, actually. If you want to take a look at this, there's an affiliate link down below in the description. That'll give me a small cut and help me run the channel for a little bit. Because running a YouTube channel is actually pretty expensive. If you like this video, thumbs up please. If you watched this far and disliked the video, thumbs down. If you have anything to say about my measuring, which is well outside my comfort zone, leave a comment down below. I'd appreciate a comment on this. And do consider subscribing. There's always room for more subscribers. If you want to support the channel a little bit more, there are channel memberships available. And I guess that's it for now. I'll see you down the bands. I'll see you in my next video. Thanks for watching. 7-3, my friends.